So, my name is Vladimir Novick. I'm an independent consultant, do a bunch of stuff in various technologies, and there's my Twitter handle if you wish to follow me. And I will talk about scuba diving. I started scuba diving a year ago. I started with just a basic course, went with my friends to Red Sea, enjoyed a vacation, then flew to California, dove in Pacific Ocean, was quite cold, but the views were amazing. Like the whole experience of being in the other world, it was something otherworldly, and the feeling of weightlessness was pretty amazing. But that was not enough for me. I wanted to be more like self-reliant diver. I want to be a good diver for my dive buddy. So I took a rescue diving course, and pretty much this is the step everyone goes in when they go into scuba diving. So I did this like pool trainings and stuff like that, but that was not enough for me. And I wanted to learn the underlying principles behind the diving, and like I'm an engineer, and you want to know how stuff works, right? And the basic course was not quite enough for me. So I want to know the physics of diving, the compression theory, and eventually I wanted to dive better, longer, and deeper. So recreational diving, I kind of did lots of specialization there, but eventually recreational diving is something that is considered no decompression diving. Is when you have timetables, you try to stick to timetables, you try to stick to the same depth, and you have these limits, you don't pass these limits. And at any point you can get to the surface and survive, basically. A little bit about physics of diving. So the underlying principles is the Boyles law. As the pressure goes up, the volume goes down. So whenever I go deeper, my lungs compress. So the air in my lungs compress. So I need to breathe twice much more air at 10-meter depth, and 20 meters is more, and it just goes on. Now the other underlying law is the Deltans law, which means that partial pressures of gases in the mix are the sum of them is equal to the partial pressure to the pressure of the whole mix. So if we think about our air that we breathe, it has roughly 79% of nitrogen and 21% of oxygen, which in total gives us 1 atmosphere of pressure, which goes to 2 atmospheres and 10-meter depth, and it just goes on. So there's a table how partial pressures change, and at some point the partial pressures of oxygen goes to 1.1 and more at certain depth. This law gives us an ability to calculate the perfect mix with the perfect oxygen percentage for the specific depth, so we will know how long that we can extend our bottom times. But there is things such as narcosis and toxicity. Whenever you go deeper, you get nitrogen is absorbed in our tissues, and we get a sense of like dizziness, lightheaded, slow reactions. Some of us feel like drunk. It never happened to me, but there are some people that feel that way. And there is something to be aware of. But the more problematic thing is the oxygen toxicity. When you go more than 1.4 or 1.6 during the rest phases, then you can get tunnel vision, tingling, potential convulsions, and death. I mean, like you spit out regulator and probably you drown if your body is not aware of you doing that. So you need to be very careful, and you need to plan your dives. Now, the whole decompression thing is based on bubble formation theory. So whenever there is a liquid and it has some pressure, right? And if the pressure is reduced, the gas of this liquid tries to escape. And if the pressure is reduced faster, then the bubbles can form, and these bubbles can form in the micronuclei sites in our bodies, which is basically our joints, and it will eventually cause so-called bends. When person have decompression sickness, and it literally feels like cramps, and go to hospital, or in worse scenarios, worse than that. So how do we stay longer, and how we go deeper? As technical divers, we dive our dive planning is based on physics. We calculate everything. It's based on physiology. We do decompression stops to release gases from tissue. So we stay at certain depth for a certain amount of time to just wait for gases to be released, not to cause decompression sickness. And we get some kind of virtual ceiling. So if something happens, we cannot escape. We need to solve that on that particular place and that particular depth. We breathe different mixes of various oxygen percentages and sometimes helium at different depth, which means we need to be really aware of the depth, because again, if we go too deeper, oxygen toxicity, death. The planning looks like that. We have a regular plan, we have a backup plan, we have a backup of a backup plan, we have a computer that is a backup for a backup of a backup plan, and we have a backup computer for a backup. So like all the equipment is redundant. We have like more time we spend there. Deeper, like this particular dive is 44 meters depth. And this is equipment. There's more equipment. This is just equipment for 2 people. We do gas switches at certain depths. So here I'm doing gas switch. I have 2 tanks on my back. I have another tank with 50% oxygen mix. My dive buddy is checking that I am breathing the exact percentage mix at exact depth. Obviously, I'm checking also my gauges. I check my computers. And my body is double checking that everything is right and I can breathe this mix. And yeah. So what is the roadmap? Right now I can dive to 45 meters depth without any limit to decompression, but the roadmap for me for next year to dive more than 100 meters, which is kind of considered the maximum level of technical diving. And it's roughly about 3+ hours of dive when you stay on 100 meters for 15 minutes, and the rest you just wait until you get out. Under ice diving, hopefully, cave diving probably the year after that, and advanced track diving, going inside sunken shapes and dive in abandoned mines. That's what I want to do. This is for now the specializations that I did. It's just the beginning. I probably will be instructor at some point as well, because it really fascinates me. The whole technical diving gives me the true weightlessness experience and feeling of space, because when you go just regular scuba diving course, they tell you feel the weightlessness, but then if you have buoyancy problems, you try to fin fast. But when you do technical diving, you have to be perfect at your buoyancy control, so you can just stay and just like sleep and hover in space, which is quite amazing for me. And just a video here how technical diving looks like. So it's like promo video of different aspects of technical diving, different tracks, and how it looks like. Yeah, it's like wreck diving, going for hours inside the wreck, going inside caves, doing like side mount diving when you have like 2 tanks on the side, something like that, which is not that fun. Rebreather diving, when you don't have bubbles coming out, you have the quietness and the weightlessness of space. Cave diving, when you, well, it depends which cave diving you do, because there are some cave divings that consider more dangerous than NASCAR driving. I don't strive to get there, but yeah. Yeah, there is the TDI thing, and that's my hobby. And thanks for watching.